Do you truly understand what ancient cannons actually looked like? We generally assume that weapon development followed a linear path, progressing steadily from rudimentary to sophisticated. Yet a careful examination of museum collections exposes a reality that completely dismantles this comfortable assumption. It appears as though two entirely separate parallel universes of artillery technology existed simultaneously in the same historical moment. The first category might be termed remarkably advanced weaponry. These are armaments so technologically refined that they appear displaced from several centuries into the future. The most extraordinary specimens reside in St. Petersburg's Artillery Museum. Contradicting widespread assumptions about ancient ordnance, they're constructed not from bronze but from superior quality steel. Each weapon features sophisticated sighting apparatus, demonstrating an emphasis on precision targeting rather than random directional firing. But the most remarkable characteristic is their engineering. Many possess rifled barrels, a technological innovation that imparts spin to projectiles, dramatically enhancing accuracy and effective range, which according to conventional historical narratives only achieved widespread adoption centuries afterward. Moreover, certain of these weapons weren't loaded through the muzzle but through the breech. They incorporated intricate breech-locking mechanisms, whether wedge or screw designs, which fundamentally accelerated reloading procedures and enhanced crew protection. These technological marvels are attributed to the 15th century, long preceding Ivan the Terrible's era. They represent engineering achievements resembling temporal anomalies, visitors from distant futures who somehow materialized in the remote past. And positioned directly beside them, within identical museums and ostensibly identical historical periods, we discover the second category, peculiarly primitive artillery. They constitute the absolute antithesis of the first classification. Characteristically, they are massive, unwieldy constructions cast from bronze. Their caliber can reach 220 millimeters, and their barrels extend exceptionally long. Yet despite their monumental dimensions, they lack the most fundamental feature, sighting mechanisms. Their breech section invariably appears noticeably thicker than their muzzle, and their mass ranges from 1 to numerous tons, rendering transportation and directional adjustment nearly insurmountable challenges. Their barrels frequently display ornamental embellishments, and at the extreme rear exists a peculiar handle terminating in a knob, whose function remains entirely mysterious. It's inconceivable to lift or rotate a multi-ton mechanism using this diminutive feature. They appear archaic, crude, and illogical from any military perspective. And this is where the fundamental paradox materializes. How could such drastically divergent technologies coexist within identical historical eras? On one hand, we possess precise steel rapid-firing weapons that transcended their temporal context. On the other, we encounter gigantic, inaccurate, cumbersome bronze monstrosities. The logic of historical progression suggests one should have superseded the other, yet evidence demonstrates their simultaneous existence. The advanced steel cannons are relatively comprehensible. They represent effective armaments, albeit surprisingly sophisticated for their attributed period. But the genuine profound enigma resides with their primitive and gigantic counterparts. Their design generates so many contradictions that it compels us to question their actual purpose. It's these mysterious giants that we shall now attempt to comprehend. Let's scrutinize more carefully the first category of these so-called peculiar cannons, the enormous bronze artillery pieces, to understand precisely how absurd they are from military perspectives. The first element that proves shockingly evident is their colossal excessive mass. We're not discussing hundreds of pounds, but tons, sometimes approaching 50. Imagine a multi-ton bronze behemoth positioned on a battlefield in an epoch lacking paved thoroughfares or powerful tractors. Relocating such an object would constitute a monumental engineering undertaking, requiring weeks, hundreds of personnel, and elaborate systems of levers and cordage. In dynamic warfare, where velocity, repositioning, and responding to enemy maneuvers prove critical, such immobility represents a fatal vulnerability. A weapon incapable of rapid directional adjustment or movement to protected positions isn't a formidable weapon. It's an ideal target. Historians attempt explaining their existence by asserting they were siege implements designed for demolishing fortress walls. According to this interpretation, a specialized pit was excavated for firing where the weapon was positioned, secured to absorb the tremendous recoil. Gunpowder and a projectile were subsequently loaded into the barrel, and a shot was discharged somewhere toward the enemy fortification. But even this explanation proves inadequate. This firing methodology only permitted shooting in one predetermined direction. The range could be somewhat adjusted through gunpowder quantity modifications. But what if the adversary repositioned their forces slightly laterally? Would they need to excavate the multi-ton machine and recommence the entire procedure? It's preposterous and inefficient. Any rational commander would prefer a dozen smaller mobile cannons on carriages that could be rapidly repositioned along battle lines, rather than one of these cumbersome giants. So, why was such enormous mass necessary if it rendered the weapon practically useless in combat? The second paradox, equally significant, is the complete absence of any sighting apparatus on these bronze giants. You'll discover no front sight, no rear sight, no mounting brackets for them. This represents a fundamental omission that questions the very concept of them functioning as weapons. Discharging any weapon constitutes an art of precise calculation. Even the most rudimentary throwing mechanisms possessed aiming devices. Firing a cannon of this caliber represented a rare and expensive event requiring enormous quantities of scarce gunpowder. The reloading procedure itself consumed hours. Was all this effort and all these resources genuinely expended merely to launch a projectile in the general direction of adversaries, hoping for favorable outcomes? This contradicts the entire logic of military evolution, which has consistently pursued enhanced accuracy and efficiency. How could you aim a weapon that was structurally not designed for aiming? Finally, the third group of oddities relates to their design particulars. Many of these weapons display cast elements, so-called dolphins, which are presumed to be lifting handles. But just attempt imagining lifting dozens of tons using these relatively fragile, decorative components. Even more mysterious is the massive handle, with a knob at the very breech extremity of the barrel. This feature is completely non-functional. It's impossible to lift, much less rotate, a multi-ton barrel using it. It provides absolutely no mechanical advantage. Interestingly, in subsequent eras during the 18th and 19th centuries, military engineers were clearly also perplexed by this feature. They attempted modernizing it, sometimes drilling holes through it for rope to restrain the cannon's recoil, or cutting threads and inserting adjustment screws for vertical targeting. But these were merely attempts to adapt an initially incomprehensible element whose authentic purpose had been forgotten for their own requirements. Thus, every detail of these cannons contradicts military logic. Their mass renders them immobile, the lack of sights renders them inaccurate, and their design elements are non-functional. They resemble anything except effective weapons. But the greatest mystery, the most crucial clue in this investigation, was concealed for decades, unnoticed inside the metal itself. It remained invisible until chemical laws compelled it to manifest. Only recently has this secret begun treacherously emerging on the noble bronze surface. Bronze doesn't rust. This is axiomatic, a fact universally recognized based on copper alloy chemical properties. Bronze can oxidize, developing a noble greenish patina, but it will never produce the reddish streaks characteristic of iron corrosion. So, what are we observing on the surface of many museum specimens? These very bronze giants. A careful observer will notice strange illogical marks and treacherous rusty streams seeping down the noble metal. These marks appear especially common around the breech, the most massive and stressed section of any weapon. A magnet adheres perfectly to these rusty locations, eliminating any doubt about their nature. Concealed inside the bronze is iron. This discovery represents the turning point of the entire investigation. It shifts the mystery from the realm of military tactics to the realm of metallurgy and rational analysis. The rust is merely an external symptom, indicating an incredible internal structure. Judging by the rust streak locations, when these weapons were cast, a framework of steel rods, usually 3 or 4, with square or rectangular cross-sections, was positioned inside the bronze mold beforehand. On certain examples, rust traces are visible not only at the rear, but also approximately half a meter from it, and sometimes rust even seeps from the touch hole. This indicates we're not encountering accidental inclusions, but a deliberately created composite structure, a steel skeleton encased in bronze. And here we encounter an engineering absurdity. Why would ancient craftsmen conceal steel rods inside bronze castings? The first thought emerging is for strength enhancement, but this theory disintegrates under scrutiny. First, it's technologically incredibly difficult. Bronze's melting point is significantly lower than steel's. This means a complex steel frame would have required initial fabrication and then somehow encasement in molten bronze without compromising the steel's structure and ensuring robust bonding between these dissimilar metals. This represents a highly complex casting challenge even for modern technology, much less for historical periods. Second, it's economically unfeasible. Steel has consistently been a stronger, more expensive, and more strategically valuable material than bronze. Concealing strong steel inside weaker bronze resembles reinforcing a concrete wall with gold bars. If craftsmen possessed sufficient steel to create a powerful internal frame, why didn't they simply fabricate the entire weapon from steel, like those surprisingly advanced cannons? It would have been simpler, more reliable, and more effective. Third, and most critically, such a design is a ticking time bomb. Any metallurgist understands that contact between dissimilar metals, especially in moisture's presence, creates a galvanic cell that dramatically accelerates corrosion. The steel concealed inside was condemned to slow but certain destruction. As iron rusts, it expands in volume, creating enormous internal pressure on the surrounding bronze. Over time, this would inevitably produce microfractures. Water would infiltrate these fractures and, upon freezing, would tear the bronze apart from within. This means the creators of these objects deliberately incorporated a self-destruct mechanism. No weapon manufacturer creating an item upon which lives and battle outcomes depend would ever execute such a thing. A weapon must be supremely reliable. Official history and archaeology remain completely silent on this matter. In books and articles about ancient artillery, you won't find a single word about steel frames inside bronze cannons. This information is either ignored or unknown to researchers. This glaring technological inconsistency strongly suggests we're not dealing with weapons whatsoever. All their paradoxes, the excessive mass, the lack of sights, the non-functional details, and finally, the self-destructing design, indicate we have mistakenly attributed a military purpose to these objects. But if they aren't cannons, then what are they? To approach the answer, we need to broaden our perspective and examine even more bizarre, even more absurd, and utterly unthinkable weapons that finally put the military theory to rest. If rust seeping through bronze seems like convincing evidence that we're not dealing with weapons, then prepare to encounter the true titans that will finally bury the military theory permanently. We're now advancing to the second category of bizarre cannons. Weapons with caliber so enormous that an adult person can easily crawl inside. These are legendary monsters like Mad Greta in Europe, or the giant cannons of Indian fortifications, such as the Malik M. Didon or the Jaivana cannon. Observing these behemoths, any military specialist or engineer would simply raise their hands in disbelief. Their existence as combat units represents a complete dead end for military thought. Let's commence with the most obvious problem: logistics. If transporting cannons weighing several tons was a nearly impossible task, then moving these mastodons weighing dozens of tons becomes pure fantasy. For example, the Indian Jaivana cannon, supposedly created in the 17th century, weighs over 22 tons and measures 7.5 meters long. The external diameter of the barrel approaches nearly a meter, and the caliber is 625 millimeters. For comparison, the main guns of 20th century battleships designed to pierce the thickest naval armor had calibers of only 300 to 400 millimeters. How was this monster supposed to be transported in an era when the only draft animals were oxen and horses, and paved roads simply didn't exist? Any attempt to move such a machine on a cart with wooden wheels would have inevitably concluded with it sinking to its axles in the ground. It's like attempting to drive a tram through a plowed field. Even during World War I, in the age of steam engines, special wheels with huge extensions had to be invented to move heavy artillery over rough terrain so they wouldn't sink into mud. And here we're discussing a time several centuries earlier. But let's assume that through some incredible effort, this weapon was brought to the walls of an enemy fortress. Now comes the second equally difficult task: loading it. The ammunition for such caliber would be enormous stone or cast iron balls weighing hundreds of pounds, if not tons. How were they lifted? How were they pushed into the barrel? Modern naval guns of similar class used specialized cranes and mechanized rammers for this purpose. What did ancient artillery crews possess? Dozens of men with ropes and levers. The loading process alone would have transformed into a multi-hour, extremely dangerous operation. And that's before you even consider pouring hundreds of pounds of gunpowder into the barrel. This entire engineering nightmare was for a single shot, which, as we remember, would be completely inaccurate due to the lack of sights. It defies all military logic. But the most devastating argument against the combat purpose of these giants lies in the realm of physics and materials science. As we already understand, when a cannon fires, the maximum pressure from gunpowder gases occurs at the breech, the rear portion of the barrel. Therefore, it must always be the strongest and thickest section. But what do we observe in these super cannons? Look at the famous Anatolian bombardier, also known as Dardanelles gun. Its design is shockingly illogical. The barrel walls have almost identical thickness along their entire length. From an engineering perspective, this is a fatal design flaw. Such a weapon is simply not constructed to withstand the colossal pressure of a shot at its rear. And history has provided us with irrefutable proof of this fact. In the 19th century, when they decided to fire a ceremonial shot from a similar ancient weapon in honor of a sultan's visit, it simply cracked. It burst apart. This wasn't the result of wear or metal fatigue. It was the predictable outcome of attempting to use an object for a purpose it was never designed for. A structure with uniform wall thickness at such enormous caliber is physically incapable of withstanding the pressure of gunpowder gases needed to propel a heavy projectile. It was never intended to. So let's summarize our investigation. We have discovered that the smaller bronze cannons have a strange and self-destructing internal structure with the steel frame. Now we observe that their even larger brethren are completely impractical from a logistical standpoint, tactically useless, and most importantly, physically incapable of firing without the risk of self-destruction. The conclusion is obvious. These giants, like their smaller siblings, are not weapons. We have looked at them for decades, but have not seen their true nature because we were asking the wrong questions. It's time for the great revelation. What if we examine these mysterious objects not through the eyes of a soldier, but through the eyes of an industrial engineer? Let's conduct a thought experiment for a moment. Let's discard the word cannon. Let's forget everything we've been told about siege artillery and storming fortresses. Let's look at these objects with fresh, unbiased eyes as if we're seeing them for the first time. What is it that we observe? We observe massive hollow metal cylinders, often with complex internal structures and strange external protrusions. They're heavy, durable, and clearly designed to handle high pressure or high temperatures. If we remove the weapon label, in what area of human activity might we find similar devices? The answer comes naturally, in heavy industry. What we're looking at are not ancient arsenals, but fragments of industrial equipment from long-vanished factories. This hypothesis, while seemingly bold initially, is actually the only one that logically explains all the paradoxes we've encountered. Let's examine it in more detail. We'll start with the first category of our bizarre cannons, the bronze weapons with caliber up to 220 millimeters, the ones that hide a steel frame inside. If this is not a gun barrel, what could it be? Let's consider the English word push. Its primary meanings include thrust, pressure, and force. The German word is Druck, which also translates to pressure and compression. Perhaps the name itself holds a clue. If this is a device for creating pressure, its design is strikingly similar to the working cylinder of a piston pump, either for water or even steam. Such a device requires exactly these properties: high strength, resistance to pressure, and durability. Now let's recall the main clue, the steel frame inside the bronze. In the context of a pump, this oddity suddenly makes sense. Bronze is an excellent anti-friction material. It provides a smooth sliding surface and is resistant to corrosion from water, but it's not strong enough to withstand continuous cycles of high pressure. Steel, on the other hand, is very strong but is prone to rust and has worse anti-friction properties. What if ancient engineers combined the best of both worlds? They created a strong steel structural frame capable of withstanding the pressure and then encased it in a durable, corrosion-resistant bronze lining that served as the working surface for the piston. This is a complex but highly effective engineering solution aimed at creating a long-lasting and reliable industrial machine. Illogical for a weapon, this biometallic construction becomes perfectly justified for a high-pressure pump. Now let's turn to the true giants, the monsters of impossible caliber. If the cities of the past were built of stone and brick, if they had complex structures like castles and cathedrals, then their construction required a vast amount of building materials, primarily binding agents like cement or lime. And to produce these materials, you need industrial kilns. Modern rotating kilns for calcining lime or producing Portland cement are gigantic horizontal cylinders that rotate slowly on their axis. They look remarkably similar to our so-called supercannons. They have thick walls designed to contain high temperatures and enormous sizes corresponding to industrial production volumes. This is no longer a weapon. It is the heart of a cement plant. But cement production isn't the only possible application. In metallurgy and mining, there's a crucial process called ore enrichment. Before smelting metal, the rock must be crushed to separate the valuable mineral from the waste rock. To this day, ball mills are used for this purpose. These are also large rotating drums into which hard grinding media, steel or stone balls, are loaded along with the ore. As the drum rotates, the balls tumble, fall, and grind the rock into fine powder. Now, let's look again at our giants. They're perfectly suited for the role of such ball mills. They have large volumes for loading ore and strong walls capable of withstanding the constant impact of grinding media. This industrial theory suddenly explains all the oddities that stumped us. It explains the immense weight which is necessary for the stability of a rotating kiln or mill. It explains the gigantic size dictated by the scale of production. It explains the absence of sights which are simply not needed on an industrial machine. And it explains why these weapons burst when someone tried to fire them. They were not designed for the explosive pressure of gunpowder. Their job was to withstand static loads and high temperatures. The picture begins to clear. What we mistook for clumsy and ineffective weapons may in fact be highly advanced for their time industrial equipment. But how does this theory explain the small but important design details like the dolphins and the mysterious handle on the breech? To put all the pieces of the puzzle together, we need to examine these elements in a new industrial context. Let's return to those peculiar design details that baffled military logic and look at them through the lens of the industrial theory. If what we have here are not weapons, but pieces of factory equipment, then every one of these oddities not only finds an explanation, but becomes an absolutely necessary and logical part of a single mechanism. The worldview where these objects were clumsy cannons begins to crumble, and in its place emerges the image of powerful, well-designed technology. Let's start with the external protrusions. The mysterious dolphins, massive brackets, and other shaped elements which were considered either inconvenient handles or bizarre decorations suddenly acquire a crucial function. Imagine a giant multi-ton cylinder, a kiln or mill that needs to be rotated slowly but with enormous force. How do you transfer torque to it from an external power source? The most obvious way is through a gear drive. These protrusions are nothing more than the teeth of a giant gear cast as a single piece with the cylinder's body. They would engage with a smaller driving gear, which in turn was powered by water, wind, or animals. Now their shape and placement make sense. They needed to be strong enough to withstand colossal loads and evenly distributed around the circumference for smooth rotation. The same applies to the smooth ring-like bands seen on many of these cannons. These are not just reinforcing hoops. They could serve two functions. First, as support surfaces or riding rings on which the entire cylinder rested and rotated on support rollers, just as it's done in modern industrial kilns. Second, they could have been giant pulleys for a belt drive. One can imagine a wide, durable belt slung over such a ring connected to the large flywheel of a watermill or windmill. Thus, what appeared to be meaningless decoration was in fact a critical part of the drive system. Now, let's move on to the ammunition. Why are piles of stone or cast iron balls so often found next to these giants in museums and fortresses? Military theory says they're projectiles, but we've already established that firing them was practically impossible. In the industrial version, however, everything falls into place. They're not projectiles. They're grinding media for a ball mill. The process was simple and effective. Dozens or even hundreds of such balls were loaded into the hollow cylinder through the wide muzzle. Then the rock to be crushed, limestone, or components for cement were added. After that, the mechanism was set in motion. The cylinder would begin rotating slowly, and the balls inside would tumble, be lifted up the wall, and then fall down, crushing, abrading, and grinding the rock into fine powder with their mass. This remains one of the most common methods of industrial grinding today. This explains why there are so many cannonballs and why they often have imperfect shapes. For the crushing process, only their mass and hardness matter. And finally, the most telling detail, the so-called touch hole. In a weapon, its function is clear, to ignite the powder charge. But if there's no gunpowder inside and a grinding process is taking place, why is it there? The answer is brilliant in its simplicity. It's not an ignition hole, it's a discharge outlet. Let's imagine our ball mill in operation. To make the process continuous, it was set up with a slight incline towards the breech end. Raw material was fed in from one end, and as it was ground and rotated, it gradually moved towards the other lower end. And right there, at the lowest point, was this small hole. Through it, the finished finely ground product, flour, cement powder, enriched ore, would continuously pour out into a special collector. The small size of the hole prevented large pieces of rock or the grinding balls from falling out, acting as a simple classifier. Even the repair marks, visible as longitudinal stripes on the inner surface of some Indian cannons, find a logical explanation. You don't repair the inside of a cannon barrel with patches, but the inner surface of an industrial mill, which is subjected to enormous abrasive wear, is regularly protected with replaceable armor plates known as liners. These stripes are the traces of such lining. Thus, every detail that was meaningless, illogical, and paradoxical in the context of a weapon turns out to be perfectly functional, well-designed, and necessary as part of a complex industrial machine. The strange protrusions become gear teeth and pulleys. The stone balls become grinding media. The touch hole becomes an outlet for the finished product. The worldview is turned upside down. Before us are not instruments of destruction, but machines of creation. So what does this all mean? The very things we have always considered fearsome weapons for destroying fortresses are revealed in a completely different light after this investigation. These objects are not just ineffective as weapons, they are their complete opposite. They are not tools of destruction, but machines of creation. The giant so-called bombards were not intended to storm castles, cathedrals, and aqueducts. On the contrary, they gave them life by producing on an industrial scale the primary building materials of that era: cement, lime, and other binding agents. The smaller biometallic cylinders in turn did not rain fire upon the enemy, but likely pumped water, draining construction sites, supplying it for industrial processes, or powering other machinery. We are not looking at arsenals frozen in time, but at the ruins of ancient industrial zones. Before us lie the remains of factories, metallurgical complexes, and ore processing plants. Every illogical element, every strange design feature that was an engineering absurdity for a weapon, becomes a brilliant and entirely justified solution for an industrial machine. The excessive weight provided stability. The strange protrusions were elements of the drive system. The absence of sights was normal for a stationary unit, and the seemingly self-destructive design of steel and bronze was actually a complex composite material combining the strength of one metal with the anti-friction properties of the other. Everything falls into place. The scale of production, judging by the size of these machines, was colossal. This speaks of a civilization that required vast quantities of building materials and processed ore. What happened next is a separate, even deeper mystery. It's likely that as a result of some global events, technologies and knowledge were lost. Production lines came to a halt. And when subsequent generations of people found these massive, incomprehensible devices, they could not grasp their true purpose. The only association a large hollow cylinder could evoke in a person rediscovering gunpowder was that of a giant cannon. And so industrial equipment was given a new history, transformed into weaponry. It was displayed on fortress walls as a symbol of power, a scarecrow for enemies. It was given fearsome names, and legends were invented about its destructive force, without anyone ever suspecting that its true power lay not in destruction, but in creation. Perhaps we should completely reconsider our views on history and the technological level of our ancestors. What if right under our noses, in museum halls and on pedestals of honor, there stand silent witnesses to a completely different technological past? A past where people knew not only how to wage war, but how to build on a scale we can barely imagine. A past whose technologies we no longer understand and have mistakenly classified as primitive weapons simply because they didn't fit into our neat but possibly incorrect picture of historical progress. This theory turns the familiar world upside down. Let us know what you think about it in the comments.